Before starting to train any machine learning algorithm, it is a very good practice to explore the dataset and have a feel of what you're working with, especially if your machine learning algorithm is something like an ordinary least squared or OLS model, because in those situations, you're more concerned with explaining the relationships and figuring out the causal impact of one variable on the other. Therefore, it is much better to have a better idea of the data set that you're going to work with. So in this video, I'm going to cover how you can explore and clean and sometimes transform the data sets that you have. This example is based on the second chapter of the book by Orlean Giron, called Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. I would put the link in the description. You can download the dataset for this example from Kaggle by just going to Kaggle and searching for California housing prices, and going to the data and downloading the data. Make sure that you download the data on a place on your computer where you're going to create the Jupyter notebook so that you can easily have access to that and import it into Python. So just like always, the very first thing that I do is to import NumPy, Pandas, and Matplotlib libraries into my workplace. And you can actually copy this from the previous examples of code that we had. It's just exactly the same. The next step for me is to read my dataset using Pandas. So I say pandas read underscore CSV, because the file that you're downloading is a CSV file, and whatever the name of the data set is, in this instance it's called housing.csv, and you put it in a data set that you create, and I'm going to call that data set housing as well. And I just run it to make sure that there are no errors. All right, let's see what we have here. So let's use the shape function to just see what we're dealing with. And when you run that, you see that you have an observation that has 20,640 rows and 10 columns. And what I'm going to do is to just print the first couple of observations to see what I have here. So I have longitude, latitude, housing median age, total rooms, total bedrooms, population, households, median income, median house value, and ocean proximity. So what we are working here with is basically the districts in California. So for each district, you have the locations in terms of latitudes and longitudes, and a bunch of features about their housing market, such that the median age of the houses within that district, or the total rooms of all the houses within that district, and total bedrooms and population and so forth. One of the interesting things here is that the ocean proximity is a feature that is not numeric, so we have to figure out how to deal with it. You can have a better feel of the data by using the info. So if you type in housing.info, you would have a description of the values of the features that you have here. So again, all of the columns are listed here, and you can also see the number of the non-null observations. In other words, it shows you how many non-missing observations you have for each variable. And one thing to notice is that while, if you remember, we had 20,640 observations, right? And there are 262,640 non-missing values for all of the variables except for the total bedrooms. Instead of having 20,640, we have 20,433, which means that there are 207 observations that have missing value for the total of bedrooms. There are, in other words, there are 207 districts for which we don't know how many total bedrooms there are. Okay, so we also have to deal with this problem here. So there are basically two things that we are going to deal with. The very first one is that the ocean proximity is not a numeric value, it's an object. And in order to run machine learning algorithms, especially in OLS, we need to figure out a solution to deal with this, because OLS does not work on observations that have non-numeric values. So that's the first challenge. And then the second challenge is to deal with the observations that have missing values. So what are you going to do with instances where you don't know what the total number of bedrooms is, and how to deal with it? Let's take a closer look at the non-numeric variable that we have here, the ocean proximity. So you can just type in housing and then specify the variable that you're interested in, which is ocean underscore proximity. And then have the value counts by just typing value underscore counts to see basically how this non-numeric variable, your categorical variable, looks like. All right. So out of all the observations that we had, which was about 20 or more than 20,000, you would see that there are 9,136 of them that have a value of less than 1 ocean, meaning that it is less than 1 hour from ocean in terms of distance from ocean. So there are 9,136 districts that are less than 1 hour from ocean, 6,551 that are inland, then 2,658 that are near ocean, near bay, and then there are 5 of them that are island. All right, so this gives you a much better idea of the distribution of the values within the column of ocean proximity, right? So now you know that there are 1, 2, 3, 4, 5 different categories within this categorical variable and how frequent each category is. One thing that may come to your mind is that, there are only 5 districts that are, island districts, and it's so unique, it's so different and so rare that it may be a good idea to just drop these observations, right? So right off the bat, it gives you some ideas about how to deal with this. In case you want to have the descriptive statistics in your data set, you just use the describe. So you just type in housing.describe. And you would have a descriptive statistics table of your data set, right? So for example, for all of the variables, you have the count, 20,000, and then you have the mean, standard deviation, minimum, and the maximum and different quantiles in your data set. So it gives further information about what you're dealing with. However, as most times when you're dealing with table, values presented in a table, it's very difficult to, understand these numbers fully, right? And a picture is worth 1,000 words. So, plotting your data would help you have a better understanding of what you're dealing with. And this is what I'm going to do right now. So I'm going to create a histogram of my data set by using the hist. So housing.hist. And then one thing that I'm going to define here is the number of bins. And I set it as 50. The number of bins is basically the number of chunks that you want your data to be split into, right? The other thing that I want is to define the figure size, and let's say that I define it as 20 and 50. So this is what we are going to have. We are going to have a histogram of all the numerical variables in our data set, and they are split into 50 parts, right? So you see that the longitude is split into 50 groups or 50 bins, and then the frequency within each bin is shown in the histogram. And then you can get some ideas here. So for example, you can see that the median house value has some outliers, right? Towards the very right, you see that there are a bunch of houses that are here. So you have to probably think of some smart ways to deal with the fact that there are houses that are priced much higher than the rest of the population, and most importantly, the fact that they are maxed out at 500,000, right? So it would hint that probably in the data collection process, researchers or whoever collected this data labeled every house that is at least $500,000 within this category, right? So if a house is $600,000, they label it as $500,000. If it's $2 million, again, it's $500,000, right? So it's there's an unusually high concentration of observations that have a median house value of $500,000. The same goes for median house age, right? It seems like the houses that are older than 50 are all grouped together. But since we have the geographical location data in terms of longitude and latitude, let's plot it and see how it looks like. So you can use the plot, and you just type in housing.plot and define a scatter plot. So type in kind is equal to scatter and define the x and y variables. So let's say that the x is longitude and y is latitude. Let's see what we get. So we get this plot which actually looks like the map of California, because these are the actual latitudes and longitudes of those districts, the over 20,000 districts in California. And as you can see that, these dots representing each districts in many parts are overlaid on top of each other. Okay, so one way that you can have a better visualization is to define a transparency using alpha, and let's say I put it equal to 0.1, and then you would see that because I've reduced the transparency, when these dots are overlaid on top of each other, they're going to create a darker blue, right? So by looking at here, then you would see that, in these areas, these are the San Francisco areas, right? And these are the Northern California areas. Which areas are, you have more observations of. Now, one thing that I can do here to use visual statistics to help me have a better idea is to see, if I can detect any relationship between different features, and if I can show that relationship in this scatter plot. You can imagine that the housing prices would be correlated with, say, the population in a district, and also obviously with the location, right? So these that this is the ocean towards the left, so probably these houses, the houses in these districts would be more expensive than the ones that are more inland, right? So what I'm going to do is to change the size of these dots based on the, say, population in the district, and also I'm going to change the color based on the house value, right? So what I can go ahead and do is to use the S option, and S stands for size. So I can say S is equal to housing, and the variable is going to be population. And I'm going to label it as population. Just let me show you how it's going to look like. It's not going to look like nice, but it's just a lesson for you. So you see that these dots are too large, right? So one thing that I can do, and that is the lessons basically, that you can justify this and adjust it. So you can say the size should be the whatever the population is divided by 100, right? So you would reduce the sizes here, okay? So you see that you have one district here that has a relatively large size, and then you have, say, this district that has a relatively smaller size, okay? So now we've adjusted these dots based on the size. One other thing that we wanted to do was to use color coding for the house values. So what I'm going to do is to say, use the C option standing for color. I say the color is the median house value Now, the color map is going to be using the CMap option, and you can just say plt dot get CMap, and then identify the name of the color map that you're going to use. In this particular case, there's a predefined color map called jet that we are going to use. And let's run it. And this is what you're going to get. So now not only the sizes are going to be representing the population of the district, but also the color is going to be corresponding to the house value, right? So the more expensive the house, the closer it is to the color red, and the less expensive houses are towards color blue, right? Now, when you see here again, you see that in these areas, in the Bay Area, you have the most expensive houses in here and here, and as you go inland, again, the prices of the houses are going to decrease. The other thing that you're going to see here is that these red dots tend to also be large, right? So these are very large districts that have high population and are near the bay and near the ocean that have the highest median house value. Now, one other thing when it comes to descriptive statistics that you can do is to just create a correlation matrix, right? So I can just say housing.core, and that would give you the full correlation table of all the pairs of variables in your data set, right? So what does correlation signify? Correlation shows how closely related two variables are, okay? Or how much one variable changes as the other one change. As you can imagine, the correlation of each variable with itself is equal to 1, which is the highest possible value of a correlation, right? So a correlation of 1 indicates that they are exactly the same. That is why you would see that the correlation of longitude and the longitude is equal to 1. So is the correlation of, say, latitude with itself, with the latitude, right? You see that it is equal to 1. Now, the correlation ranges between -1 and +1, okay? A +1 correlation means that they are exactly the same, and a -1 correlation means that they are exactly the opposite, all right? And a correlation of 0 means that there is no relationship between these two. So the values that are closer to 1 or -1 mean that those variables are more closely related. Now, there is a lot of information here, and it would be interesting to go through all of it. However, it would be much easier to digest if you only looked at the correlations between the median house price and all the other variables rather than having such a gigantic table. So to do that, let me put this in a table, and I call it a correlation matrix. All right. So basically, once I do this, I'm creating a table that puts the correlation matrix that you just saw into a table called core underscore matrix, and then I can just ask for a specific column in that table. So I just say correlation matrix, and then define the column that I want. And the column that I want is the median house value, right? So median house value. And not only I want that, but also I want it to be sorted, because then I am going to see the most important or the highest correlated variables at the top, right? So I just say sort values, which is the function that is going to sort the values within a column for you in Python. So sort underscore values. And then because I want the highest correlation to be at the top, I want to have a descending order. And in order to have a descending order in sorting, you have to use the ascending option and equate it to false. So I'm going to say ascending, and I just say equals to false. Now let's see what we get. That is the correlation of the median house value with all the other variables, including itself, in a descending order, right? So you would see that the house value is very highly correlated with the median income, which makes total sense, right? Where rich people live, the houses tend to be more expensive. Now, we also have a negative correlation here. We have a somewhat weak correlation between the house prices and latitude, and it is negative. What it signifies is that as you move up north, in other words, as you increase your latitude, the house prices decrease. So there's a negative correlation, meaning that the houses up north tend to be cheaper than houses towards the south of California. All right, now let's see how we can deal with the fact that the variable for total number of bedrooms had missing values. Well, there are a bunch of things that you can do about it. The very first one is to drop this whole feature completely and say that, you know what, I'm not going to worry about the total number of bedrooms. Well, if you do that, you're going to lose a lot of information, okay? And you don't want to do that. The second one, the second approach is to say that I am going to drop every observation with a missing value for the total number of bedrooms, all right? That is not optimal, but at least it's much better than the first option. Rather than losing the whole feature completely, you're going to keep and retain the feature. Instead, you're going to drop 207 observations from your total 20,000, over 20,000 observations, which seems like a good deal, right? If you wanted, you could think of some ways to impute the value for that and say that, yes, I don't know what is the median number, what is the total number of bedrooms for this particular district, but is there some way that I can make a very good guess? Can I use the median value for this variable and just assume that it is something very close to the median value and use that instead? So that the imputation is going to be another approach. What I'm going to do is to just drop those 207 observations for which the value of this variable is missing. And for that, you got to use this function called drop NA. So I just say housing dot drop NA, and I say subset is equal to the variable that you're looking for. So total bedrooms, right? So basically what I am doing here is saying that drop all the observations in which the value for the total number of bedrooms is missing, and then I am asking Python to put it into a new table, which I am going to call housing and underscore NA, all right? So basically what I'm creating here is a new data set called housing underscore NA, which has fewer observations, to be precise, 207 fewer observations. And the unique thing about it is that all the observations with the missing values for total bedrooms are cleaned from the data set, dropped from the data set, okay? So let me run this, and just so you see, let me look at the shape of this new data set. So I just say housing underscore NA dot shape, and you would see that instead of having 20,000, how many, the 20,600, I think 700, now we have 20,433 observations. It's because the 207 observations are dropped from our data set. So this is what we are going to work with. Now let's discuss how we're going to deal with the categorical variable. What we're going to do is to turn that categorical variable to a series of dummy variables. And how does that work? Well, for each of the categories within that categorical variable, we are going to create one dummy. And dummy variable is a variable that is a binary variable, okay? It's either going to be 0 or 1, okay? So here, for the ocean proximity variable, which is a categorical variable with 1, 2, 3, 4, 5 categories, what we're going to do is to create 5 binary variables, and each binary variable is going to be either 1 or 0, depending on the value of the category in the ocean proximity. So, for example, we're going to create one binary variable that called inland, all right? That is going to be 1 only if the district is inland. Then we're going to have another binary variable called near ocean that is going to be 1 only if the category of ocean proximity is equal to near ocean, right? And to do that, we are going to use a function called getDummies. All right, let me show you how to do this. So you're going to go and just say PD, and PD, remember, that's the name that we gave to pandas. So PD dot underscore, get underscore dummies. And then you have to identify the name of the data set that you're working with. In this particular case is housing underscore NA, and the variable for which you want to get the dummies for, and that is ocean proximity. All right. It is going to create the dummies for you, and I'm going to put it in, give it a new name, say dummies, right? So let me run it. It runs, and just so you know, let me print dummies, and you would see that you have 1, 2, 3, 4, 5 dummies, right? 5 dummies that are either 0 or 1, depending on the value in the categorical variable. And for the first observation, near bay is equal to 1 because the value of the ocean proximity variable was near bay for the first observation. One thing to note that is that all of these dummies are going to be 0 except one of them, right? Because there is only one possibility for ocean proximity variable for each district, right? It is one of these 5 choices, okay? And you see that for all of the first 5, they were near bay, therefore everything is 0 except near bay. And for the last 5, they were all inland. Therefore, everything is 0 except for the inland. Okay, so now we have created a new table basically that has these 5 binary variables, but it's not useful for us because we have to find some way to attach it and glue it back to our original data set. We're going to concatenate it using the concat function for pandas. So I'm going to create a new data set called housing_NA_dummies, which basically means that there are no missing variables here, and also it includes the dummies. And I'm going to say it's equal to pd.concat. All right, and now we have to say what we are gluing together, right? What are the 2 data sets that you're gluing together? And those are going to be housing_NA, right? The original data set based on which we created these dummies, and also the dummies themselves. And make sure to use the option axis is equal to columns. Okay, now it's run and without any errors. Let's just take a look at the first observations to make sure that everything is actually done correctly. And this is what you get. So for the ocean proximity, you see that it was near bay, and near bay is equal to 1. Everything else is equal to 0. Okay, so we've done really good so far. Now, what we have to do is to go and drop 2 variables from this semi-final data set. What are those 2 variables? The very first and obvious choice is that we have to drop ocean proximity, because if we keep ocean proximity, then the OLS regression would not run because it is a categorical variable. And we know that the OLS regression only runs on numerical values, right? So in order to avoid any headache and any errors in the future, we have to drop the ocean proximity here. One other thing that you have to drop is one of these binary variables depending on your choice. And the reason is a very technical term in OLS called multicollinearity. If you keep all these variables, your OLS regression would not run, simply because their correlation between each other is going to be 100%. So just take my word for it. Whenever you create binary variables for a categorical variable, you have to drop one of those variables, okay? And then it's going to be depending on your choice. What I would recommend here is to drop island, because we know that there are only 5 observations that are in an island, right? So there are 5 of them that have a value other than 0. Let's drop that one. So what I'm going to do is to create a new data set. Let's say I call it housing final, or let's say call it housing clean, right? And it is going to be the same data set that we had before. The only difference is that there are 2 columns that are dropped. So I just type in .drop, and then the name of the columns that I want to drop, which are ocean proximity. Just copy and paste it from here to make sure that I don't make any typos. So ocean proximity, and the other one is going to be island. And again, make sure to type in axis is equals to columns. And I'm going to print the first observations to make sure that everything's as we wanted. And yes, it is, because now you notice that you do not have the ocean proximity variable here, and there you only have 4 binaries. The island binary has been dropped. All right, so now this data set is ready to go for OLS regression. In the next video, I'm going to actually show you how to implement the OLS regression.